dot plus omega phi double dot omega dot. This is one equation of motion in phi double dot. My second equation of motion should give me something in r double dot. That's going to come from here. Okay, so these two are my equations of motion. All I'm doing is, after all of this calculation, we have now obtained expressions for the friction force in terms of the problem parameters. So Ft is minus m times r dot sine alpha. R dot cosine alpha by tan alpha is r dot cos squared by sine alpha. This is equal to, with your permission, I'll just rewrite this term without writing the components of the acceleration. Okay, so this is this one here. This is NAR sine alpha. MV3 cosine alpha, Mg cosine alpha plus spring. Capital M is known to us right here. Normal force is known to us in terms of the problem parameters. So you can see how much effort is involved in calculating the equation of motion and then simulating this in MATLAB. You have to have all of this ready before you throw this creature into MATLAB. When you write the simulations in MATLAB, my quick question to you, I have a couple more minutes, is everybody familiar with the idea of state variables, state space approach to writing differential equations? Or would you like a quick refresher on that? A quick refresher, maybe very, very quick refresher next class. Not today, next class. So system dynamics we typically go over it, but it depends on the instructors as to when they go over it and not. So I'll very quickly take an example case, write the state space representation, and then we'll try to simulate the problem in MATLAB. So if you want to bring your computers next class, please bring it ahead, and you can type along with it. Okay. The challenge will be to simulate something like this. And I have the files, I have the codes for simulating something like this. What I typically do, if you're going to have MATLAB assignments, I will give you the code, but the code is wrong. So you will have to figure out, by obtaining the equation of motion, checking to see if what I have lines up with what the code has, change it in the places where the code requires those kinds of changes, and then see if the motion makes sense. And hopefully by the end of this semester you'll be able to write, for even rigid bodies. Okay? So we'll start the MATLAB procedure very soon. Thank you for your patience. These are not easy problems to sit through.